Hi ladies, in this video I'm going to start with the textbook theory because I was quite surprised when I saw that it starts with this formula and you're not going to need to know this formula. It's so interesting to see. I'm going to read through how to interpret it, but I've never in all my experience of teaching further maths seen the application of this formula. So R, Pearson's correlation coefficient. So remember, it tells you the strength and the relationship between two numerical variables. So N, the number of data. Your X value minus the mean of X divided by your standard deviation of X, and then your value of Y minus the mean of Y over the standard deviation of Y. And you do that for every point X, Y. This funny looking E just means the sum of. Again, you don't need to know that. So if you're happy to go, okay, good, let's move on, then fantastic. So this is important at the bottom. So Pearson's correlation coefficient R is rather tedious to calculate by hand and is usually evaluated with the aid of technology. Yes, you only need to use your calculator. So in this example here, let me just get the calculator up. Okay, we'll just make that smaller. We'll go through how to do this on the calculator. So if you've got a document already open, it's probably a good idea to open a new one. We don't want to save anything. And we're going to add lists and spreadsheet. So when we're doing bivariate data, this is going to be, or what we're doing now is going to be what you'll be using to do your scatter plots, which we've already covered, but also your linear regression, which we'll cover shortly. Okay, so we've got, let's have a look at the question, might be a good idea. So I'll just scroll you over. The following data shows the per capita income. So per capita, just the number of people, the population, in $1,000 and the carbon dioxide emission in tons of 11 countries. So determine the value of Pearson's correlation coefficient R for these data. So we've got income and CO2 tons. So carbon dioxide measured in tons. First of all, decide on which is your explanatory and which is your response variable. So I guess the wealthier countries, so a higher income, would create more carbon dioxide because they'd probably be more, have more industries, have more cars on the road, stuff like that. Okay, so when putting it into your calculator, we write the variables, so income and CO2. So I always thought you couldn't write 2. Oh, actually, in a previous maybe it's in the equals. Okay. Sorry, I'm just talking to myself. I always thought you couldn't put 2 in there. Maybe it's just symbols you can't put in. Okay, so let's put our values into the calculator. You don't need to write 23.0. You can just write 23 and then 8, 18, 16.7, 5.2, 12.8, 19. Oops. Oh gosh, what have I done? Let's go back. 5.2, 12.8. This is me rushing. 12.8, 19.1, 16.4, 21.7. Okay, so you don't want to make any errors. So always check your values just so they look okay. All right, so 7.5, 12, 6, 1.8, 7.7, 5.7, 3.8, 5.7, 11, 9.7, and 9.9. Okay, so just quickly check your values, make sure they look okay. All right, so when we're doing any linear regression, so eventually we're going to get a line of best fit, which we call our regression line, and we get a regression equation. So we just go to menu. I'm trying to remember statistics, stat calculations, and see there's 2 for linear regression. Both of them are okay, but we tend to, in statistics, use the one at 4, so A plus BX. So click on that. Then you get this box. So this is why it's a good idea not to use X and Y. So we know that our X list is income, your Y list is CO2, but you can use X, Y if you want to, whatever works for you. I'll just move this calculator over so we can see it. All right, I'll explain some other things to you before we get to R. So your regression equation, it tells you what form it's in, A plus B times X, and then it gives you your value of A and your value of B. It then gives you R squared, which is your coefficient of determination, and I'll explain that later. Not in this video. And then you got R. So there's your value of R, and just to check that we've got the right value, let's see what we've got. Okay, so it's 0.818. Usually we do to 2 decimal places. Here it's got it to 3 decimal places. Now, if we were to interpret that, I'm just going to scroll back up to the previous section. And then we use this table to interpret it. So 8.18 is here up the top. So it's a strong positive linear association. All right, so I was just having a look in the textbook for another question that we could perhaps do. So I'm just going to scroll this. Oh, it's not moving for me. Let's move over a little bit. So question 4. So the previous ones, they're all pretty similar. But let's do question 4 together. So in a survey of 9 problem gamblers, the respondents were asked the amount in dollars they had spent on gambling and the amount of hours they had spent gambling in the past week. This data collected is recorded in the table below. So question A, the aim is to predict the amount of money spent on gambling from the time spent on gambling, which is the explanatory variable and which is the response variable. So you can get that from reading the question. We're predicting the amount of money spent on gambling from time spent. So money spent, amount of money spent is your response variable and hours is your explanatory variable. So obviously the longer you spend gambling, the more money you're going to spend. All right, so constructing a scatter plot. So you can just do this on your calculator. Just go to a new document. It's probably the easiest thing to do. And add lists and spreadsheet. So we got hours and amount, and then just put in your values, correctly. 20, 21, 25, 35, and 40. Okay, and then other one, 500, 530, 300, 750, 1,000, 1,200, 2,000, 2,300, and then 5,000. Good. All right, so constructing your scatter plot. So we're going to add a page first. So add data and statistics. Down the bottom, our explanatory variable, so hours, and on the side. So I did do a video on this previously. I can't remember which section it is. It looks a bit curved, but that's okay. C, determine the correlation coefficient. So let's go back. Yeah, I think you can do it from this window. Let me just check. I'm just trying to remember. You can go to regression, show linear. Okay, so you can get the linear equation. Oh, it's not giving me R. Okay, so let's go back to our list. Just move your cursor to the side. I always go up. I don't think you need to, but all right, so then menu. So we're calculating R now, doing question C. So statistics, stat calculations, linear regression, and then we had hours for X, amount for Y. So okay, and then you get your values. So you can see you can get your equation from here too. Just see how when I hover over that cell though, it only has it to 1 decimal place, but it has the fuller number here. Okay, so more decimal places. So that's a little tip for the future. If you've got, it's not to enough decimal places, you can see I hover over and it's written it there, but it also writes a number here and that changes as I go down. All right, and then your R value there is 0.92. Okay, so we've got last question is describing the association between the variables. So 0.92 tells us it's positive, okay, because R is positive. 0.92 means it's strong. It did look quite curved to me, but because R is quite high, I'm just thinking because this value here kind of makes it nonlinear, but I'm just going to call it linear for now because it looks, yeah. Yeah, it looks, no, well, let's go with linear. All right. It'll probably be more obvious, girls, if it was nonlinear. Then question 5 is quite similar. Okay, so read through that question. I'm sure you'll be fine. All right, bye, girls.